Hello and welcome back. And my name is Olayinka I, Arimoro, and it's a huge honor to be walking you through this introductory to R series. Okay, so this is the second part in this three-part series. I want you to, if you have not watched the first video in this series, please go back to make sure you watch that video because again, it is lines upon lines, precept upon precept, building each block of the foundation. So if you have not watch the first video, please go back there and watch it. And in this video, I want us to walk through the data structures in our. This is very critical. I would anticipate that it will be probably longer than the first video and the third video because it is the core of R. It is the major building block of R. Okay, some recap here. In the first video, we talked about what is R and why you want to learn R. We got familiar with the R studio interface. We looked at some things on variable assignment, looked at some things on computation in R, particularly looked at some basic data types, numeric, character, um, logical, factor, categorical variables, and I talked about what a variable is and would reiterate that here before we start looking into data structures. And at the end of today, I just want to quickly talk maybe for 5 minutes about missing values in R, and we'll see that. Okay, so just to recap on some of the things we said in the last time you had me talk about function. So a function is simply a chunk of code that is being written to perform a specific task. All right. R comes with many inbuilt functions like the mean to check the mean, the median, the summary, the t-test, the t-test, call.test, and so on. And like last time we saw that we could check for help for these functions if you don't know about them. So I want you to pause right now and go back to your R Studio interface and try to check for help of print, check for help for write.csv, check for help for plot in R. Okay. And once you have done that, you can continue with the video. Amazing. Welcome back. I hope you were able to do that. Just go to your R Studio and you'll see me when I switch back to my R Studio. You just do question mark, the function name. All right. The last time as well, we looked at that variable data can come from different types and how you can recognize them. And we talked about the most common types. There could be much more, but these are the most common types. We talked about numeric, is also known as float. It is represented with a symbol DBL. When you load in a data, you see that. Character is a string or text. We saw that with hello world. Logical is a Boolean true or false variable. Okay. So today we want to talk about data structures, and the way I thought about doing this is I will introduce the first data structure, go back to R, walk through it, okay, come back to the second and third and fourth like that, so that it's easier for you to grasp the concept instead of just throwing everything at you at once. Again, my tempo might be a bit faster than the first video, but I'll make sure that I reiterate on, emphasize on the key point or the key things you must take away. All right. So the data structure we want to look at is what I call vectors. Remember, I talked about this at the end of the last video. A vector is a sequence or a collection of data elements of the same data type. If you probably in high school or something, you must have learned about the vector. A vector holds the same data type, basically. All right. And members of a vector are called components. To assign a vector in R, you can use the vector keyword, but usually to create a vector, we use the C function. All right. So to avoid confusion, mostly you will see the C function being used to combine to create a vector, and usually it's used to combine elements into a vector. All right. So I can create a vector called vec, and this is a numeric vector because it's holding numeric values like 14, 26, 38, and 30. Okay, that's a numeric vector, and I'm calling it vec. All right, remember that I can call it a name that is a bit descriptive. Okay, and the final thing we want to talk about vectors before we switch to R Studio is assessing a specific element of a vector, or what we call indexing a vector. And we can simply do that by calling the vector name, the variable name, and the position. And because of this point I've said, I want to also introduce a very key concept in R, that unlike some other programming language like Python, R is not zero-based indexed. What that simply means is that in R, let me get a pen. Let me get my pen here. Okay. In R, each of these elements are indexes. Okay. Unlike Python, in Python, the 14 is said to be at position 0, for example. But in R, 14 is in position 1, 26 is in position 2, 38 is in position 3, 30 is in position 4. All right, so this is why I said it's not zero-based index. And this is quite intuitive because that's one of the issues I personally have when I move from R to Python, because I usually forget that Python is zero-based indexed. Okay, so point I'm trying to make is to index a vector, to get an element from a vector, the position of a element in a vector, you call the vector name and the position. So if I want to return 38, okay, 38 is in position 3. Okay, so the way I would do that is simple. I'll call the vector name vec with a square bracket and call the position where that is, right? So can I ask you to please get the position for 14, position 14, and the vector 14. So that vector is in that element rather, or the component 14 is in position 1. Okay, having learned that, we can now switch back to our studio to walk through vectors. All right. Okay, and this is where we left off the last time in our RStudio interface. So I'm just going to open the file we'll be working with. It's the second file. I think I called it yeah, Introductory to R Part 2. Okay, and this is what we'll be working with. And I'm just going to clean off this Control L. And now we want to talk about data structures in R. So the first data structure is vectors. We would walk through this, and I want you to come along with me. So we'll use the C function to store several values in one variable. So yeah, I want to create a vector. I call it grade, maybe grade of some students. One student got 72, 176, 188, 160, 55, 164, and 199. So there are like 6 elements or 6 components in this vector called grade. So I'm just going to run that, and that runs correctly. Remember that because it's stored in a variable, we can't see the values there until we call or we print it. So I'm just going to do grade. Okay, I'm just going to print that, and you will see that printed out. Control Enter there. We can check the class. I think you learned this the last time. Class is to check the data type. So I'll run that, and it's a numeric vector. Okay. We can introduce a new variable, a new function length. And of course, just like I said, when you come here and do question mark, for example, plot, you'll see this help function. So it tells you, are you talking about the plot in the graphics package or in the base R? So this one, it opens the description for you and gives you examples, the description, the arguments it takes, the different type of things you can plot there, the label, how to give a title using the main function. You probably see that. I don't think I'll cover graphics today. That's making plot. I'm not sure it's part of this 3 series. So you can give X label to X lab title, Y label to give the Y label, Y axis the title, and other things like that. Same thing you can check for length. Okay, question mark length, and you see that it gets the length of a vector. It also gets the length of a factor, length of a list. We'll see list is also a data type as well. And so you see the different things you can do with length and the description. So you can take a minute to read that maybe later. All right, but length is to check the length of the vector, how many elements are in the vector. So if you run that, it tells you there are 6 elements in the vector. And all of these things will make sense when you start doing more advanced stuffs. When you want to check, for example, you want to assign something to the length of the data set, like the number of rows in the data set. Although you could use number of rows to n rows, I think you will see that as we go on as well. You can sort this in ascending order or descending order. So this is where the boolean comes in, or the boolean, the true or false. So in this sort variable, in this sort function, why do I keep calling functions variables? Okay, when I run this, checking the help file for sort, you see that in the argument, it takes an argument called decreasing. Decreasing, it gives you the description. The description is that decreasing is a logical, and it can sort it increasing or decreasing order. All right. So is a logical, meaning it can take true or false. So I can write out in caps lock actually true. When I run that, you see that it sorts it in the descending order. I can also just use T. Just use the T, capital T. That's as well true. And that will also run. And of course, because this is false by default, if you do not include this argument, by default, decreasing is set to false. So arguments usually are built with default too. All right. So that's why when we run the sort in the first part, it just sorted it in ascending order. But when we now specify that we want it in the decreasing order or this then descending order, it worked correctly. Okay, I hope that makes sense. Now we can create a character vector. And this character vector is just A, B, C, D, E, F. And of course, using the vector function C to combine that together. And I'm calling this vec1. So I'll run that and print vec1. All right. Now I want to take a pause right now and try to get a class of this, the data type of this vec1 and length. Can you try that? Okay, welcome back. I hope you tried that. You just use the class function and do vec1, put the variable name, and it tells you it's a character. That's a character vector. You can check the length as well of vec1, and that is also 6. All right. Let's clean up our console a bit more. I hope what we have looked at in the past few minutes makes sense. So we have seen how to create a vector, how to check the data type of a vector, how to check the length. The next thing we want to learn is indexing. Okay, so I can just come to, that's a function of the console as well. You can just quickly come to your console and print out something like a variable you have created. Okay, so here I'm asking you to return the third grade, or the third grade here is 88. Okay, so I'm going to run that. Now remember what we looked at on the slide. You call the variable name or the vector name and the position. 88 here is in the third position. All right, that's why we're saying 3. Okay, I'll run that and it tells me that it's 88. Now let's go on to return the first, second, and third grades. And you'll see this as well as we go on. It's a vector operation, the colon. So when I do 1:9, that lists me, creates a vector of 1 to 9 actually. If I do 5:19, it creates a vector 5 to 19. So basically, if I say return the first, second, and third grade, I could have done this and said grade um um with our square bracket and put 1, 2, 3. So remember what the C function helps you to do is to hold multiple things. So basically I'm trying to say return the first, second, and third grade, but I don't want to do it one at a time. I want to return it all together. So when I run this, you see that it returns 72, 76, and 88. Okay. And of course, if you come here and do C 1, 2, 3, that returns 1, 2, 3. Same thing if you do 1 column 3, it also returns 1, 2, 3. So meaning that you could do multiple things, the same thing in multiple ways in R. Okay. So that's why when I do 1 column 3, it's just me saying 1, 2, 3. I hope that makes sense. So I'm going to run that 72, 76, 88. What do you think will be the result of this when I do -1? I want you to think about that a bit. Remember, if I clean this off and print grade, grade is 72, 76, 88, 55, 64, 99. When you do -1, when you put position -1, what does that mean? What does that tell you? So when we print that, you see that -1 just, you're just trying to say, take out the first value. That's what it's saying. All right. And you will notice that, good point. Let me make a point to this. If for example, I come here and do new grade, let me call it a variable new grade, and save this in a new variable new grade. All right. And run this. I can print this and say new grade. So it means that I can have two variables. One is grade, one is new grade. All right. In the same environment. But when I did not create this variable here, I could have just kept doing grade -1, and it won't change the original variable grade because I did not save it in a variable. If I had saved this in the same variable grade, it would overwrite what I had before. I hope that makes sense. I can replace the third variable. In this, for example, the third variable in grade is 88. Let's assume I made a mistake. I can change that to 87, just reassigning it to 87. So third grade is 88. I want to reassign it to 87. So I'm just going to run that, Control Enter. And now when I Control L and print grade now, you'll see that the third grade is now 87. I hope that makes sense. And I want you to pause for 1 minute right now. Look at what we've looked before. Now do this quick exercise. Create a character vector called vec1. And it could be any character vector actually. And I want you to print the vec1. I want you to check the data type and the class and retrieve the first, second, and third grade of third characters rather in the vec1 vector. Can you pause right now and try that? And once you're good with that, you can continue the video. Okay, welcome back. I hope you're able to do that. I just copied what we had created earlier, created vec1, print it out, check the class, check the length, and print the first three variables, three values or three characters in vec1. All right. I want to also show something with this example. Let's assume we create a character numVec. That is a vector that takes both character and numeric. 10, 20, 30 with slotting in one character there, A. Okay, let's run it and print it out. I want to ask you a question, and I want you to think deeply about this. What do you think this will return? What do you think the data type would be? when you check the class of this. All right? Can you think about that for a minute? And let's see. It's a character. But the question is, when there is a 10, there are 3 numeric, but only 1 character, but it's a character. And that's to tell you that a character supersedes the numeric. That is, in this kind of setting where you have numeric and character in the same variable, it will change the data type to a character. And that's why you have to be very careful. So when you load in the data, a column can have, for example, ages of people, but one singular wrong imputation, or during data entry, somebody just mistakenly put 20A or something. That will make that column a character column. And so you now have to do things like data validation, check it. You can now, like we looked at in the first video, change it from character to a numeric and things like that. All right, those possibilities exist. But the point I'm trying to make here is that a character oversees or supersedes a numeric. Okay? Let's look at some operators in vectors. The same way when we did Control L now to clean up, when we did 1:5, that takes us from 1 to 5. We could have used the seq function, which is a sequence function, to say I want to go from 1 to 5 and I want to go by 1 step. All right, that will return the same thing. It's the same thing as doing 1, 2, 3, 4, 5. It will also return the same thing. So that's the first thing we want to introduce, this seq function. You can take a moment to read about it by doing your question mark seq. But basically, it takes an argument from, it takes an argument to, and it takes an argument by. The advantage of this over your 1 column 5 is this will only go in 1 step. So with the seq function, you are flexible to go in any step. You can go by 2 steps. So you see from 1 to 14, 1, 3, 5, 7, 9, 11, 13. You can go by even 0.2 step. Okay? And you see it goes from 1 to 14, but in steps of 0.2. All right? So that's the point of seq. And I think I went ahead of myself to say, what do you think this will return about? I think that's clear. It goes from 5 to 10 in steps of 0.5. And of course, as you know, these are vectors, numeric vectors, for example, and you can save this in a variable. So I can save this in a variable called by 0.5 vec, for example. All right, this is a variable name. And if I run this, of course, the result will not be printed out like this, but I have to call it and say this is just a name. It might not be the best name, but just something to work with. And you see it prints out 5 to 10 in steps of 0.5. All right, that's one. The second one is, the second vector operator is a rep. Rep helps you to replicate or to repeat. So basically, if I want to repeat 2 4 times, so if I run this, so it repeats 2 4 times. All of these are basics that will help you as you go on. I can also repeat each of these vectors 3 times, or each of these values again. You see that I can put it as a vector too. So I run that, so I can repeat 3, 2, 3, 4, 2, 3, 4, 2, 3, 4, 3 times. Remember, we had grade, okay? If you run grade, remember grade, the grade we had earlier? If you put times, so that will repeat it 2 times. So you see, it repeats the grade 1, then repeat again grade the second time. All right. The third case is you can repeat each element in the vector 2 times. So remember, times repeats the whole vector the number of times. But if you want to repeat, for example, 2 times, 3 2 times, 4 2 times. So for example, I have 2, 3, 4. So if I use the argument each instead of times now, and I run this, so it returns 2 twice, 3 twice, 4 twice. So So I can change each to say 5, and it returns 2 5 times. It returns 3 5 times, and 4 5 times. So these are one of the ways you work with R. You change the argument to see what that looks like. All right. And the final case is if I do times 3 and each twice, let's see what that looks like. Okay, let's clean the console. Let's run that and see. So it returns each of these 2 times, 1 2 1 2 1 2, and returns them 3 times. So 1 2 3. Okay, so I want you to pause the video at this point and see if what you just saw makes sense to you. All right, perfect. All right, the next operator we want to look at is relational operators, and you will see this being used a lot as you do more advanced work. Let's create a vector num1. 2, 6.5, 8, and 11 are the elements. Num2, 8, 1.5, 9, and 11 are the elements. Let's create those 2 vectors. You can definitely print out those vectors. Print out num2 as well. And that print out. So let's see some relational operators. One of them is greater than. So in R, to write greater than is just use your greater than symbol. So what it's doing is it will check each of the elements here and each of the elements here and returns a boolean. So for example, is 2 greater than 8? No, false. Is 6.5 greater than 1.5? Yes, true. Is 8 greater than 9? False. Is 11 greater than 11? No, false. I can also do the less than, and it's the same thing. 2 is less than 8 is true. 6.5 is not less than 1.5, you say false. 8 is less than 9 is true. 11 and 11 are not less than or greater than each other, this false. I can also do greater than. I like this, my laptop, because it just makes it so aesthetically pleasing. But what I've just done here is greater than and equal to. But my laptop just changes that. So this is what I did actually. For your own laptop, it might just be greater than or equals to. So for you to do greater than or equals to is just to do the greater than and put the equals to in front of it. So greater than or equals to. So I can write it here. So this is greater than equal to. Again, it changes it anyways. You can do less than and equal to. It changes it as well. Okay, so let's now do greater than or equals to. You'll see here that it changes a bit, because for 11, it becomes true. The other ones remains the same thing for greater than. If you do less than or equals to as well, you see it's also true because of the equals to sign. For R, when you want to do a relational thing where you are trying to check if 2 things are equal, you have to use the double equals to. And you'll see this a lot as well. When I run that, every other thing is false. Only 11 is true because 11 is equals to 11. And not equal to, again, this my laptop just changes the sign. But basically what it is the exclamation mark and equals to. So when you do exclamation mark and equals to, that's not equals to in R. But my laptop just changes it anyways. So when you do exclamation mark and equals to, that is not equals to in R. So let's see. I believe it will be opposite. Every other thing will be true, and only 11 will be false because 11 is equals to 11. So not equal to will be false. I hope that makes sense. I think we've seen this operator of 1 to 11 before, 1 to 10 rather. And num3, I think we've seen that before. The final thing I want to do is, if I set a value as 3, I can use this operator percent in percent to check if this value 3 is a num3. Okay, remember num3 is 1 to 10. So I can use this. These are just operators I'm introducing that you will probably see across your R learning journey. Okay. So I want to check if 3 is in this vector num3. All right. Remember, we set value to be 3. So I'll run that and it tells me it's true because 3 is in this. So if I change this to 30, for example, and run it and check is 30 in. So this is the in operator. You see that used a lot as well. Okay, so I hope vectors make sense. From here, we just kind of build upon it. Matrices and data frames that we'll see next are very similar, and the list just brings everything together. Okay, let's talk about matrices. A matrix is a sequence or collection of data of the same data type. The only difference between matrix and vectors is a matrix is a 2D rectangular object. A vector is just one dimension. So a matrix has rows and columns. So think about your table, your data, for example, there are rows and columns, right? And a matrix, to create a matrix, you use the matrix function. We put the vector, of course, it builds on vector. You specify the number of rows you want, the number of rows, and the number of columns, okay? And then, of course, you call it my matrix or whatever name you want to call it. And because it's a two-dimensional object, to index it or to get a specific value, we have to put two coordinates. That's the only difference. And you must learn this very well because it's the same idea for data frames as well. So because it has two coordinates, rows and columns, you have to specify two things. Unlike vectors, when you just specify only one place. Okay, so we would check, if I want to check the element in the ith row and jth column, I just put the two positions. If I put only one of them, for example, I, it returns the entire row. If I put J, it returns the entire column. So let's see some examples, all right? Of course, it will be in square bracket. Let's see some examples. So, for example, if I have a matrix like this, let's say 2, 3, 4, 1, 2, 1, and 0, 3, 6. This matrix has 3 rows, 1, 2, 3. I always tell people a row is like when you're lying down, all right? So 3 rows and 3 columns. So when you're standing up is a column. 1, 2, 3, okay? 3 columns, okay? So 3 rows and 3 columns. That is what a matrix. So the way you name a matrix is rows by column times column. I think this was probably covered in high school. Okay, so 3 rows and 3 columns. So point I'm trying to make is if I want to retrieve number 2, I know number 2 is on row 1, okay, and column 1. So what I would just do is maybe I call this my mat 1. I'll just do mat 1, then 1, comma 1. That is row 1, comma, column 1. I hope that makes sense. If I want to get this number 3, this particular number 3, I just need to know the rows it falls in. It falls in row 3 and in column number 2, right? Column 1, 2. So I just say mat 1, okay, column row 3, comma, column 2. All right, I hope that makes sense. And so I can return the second column by just saying mat 1 and then put a comma and put number 2 to specify the column. I can return the 5th row by saying, for example, mat 1, although this matrix doesn't have up to 5 rows, and just put the number of the row and just put column and nothing for the comma and nothing for the column. I can return, okay, and I think that's what I have here. I can return the 3rd row and the 1st column by doing the matrix name, 3rd row and 1st column. So this is row by column. Okay, I hope that makes sense. Okay, so this is a very important thing you will learn, and you'll see it from the example. Again, it is rows by column and is separated by a comma. All right, just to test your understanding, if I say return number 1, this number 1, what do you think would be the result? And I want you to pause for a minute to tell me that. Okay, you can't see me, so it's on the second row, row 2, row number 2, and column 3. So that will be mat 1, square bracket, row 2, and column 3. Row 2 and column 3. All right, I hope that makes sense. Now let's switch back to R to walk through matrices. Okay, now on matrices. Like we said, remember Control L. You remember your grade is 72, 76, 87. We changed the 88 to 87, 55, 64, and 99. All right. I can call the matrix function. Of course, you can also read about it. There is help for all of the functions that are in R. Okay. When you read about matrix function, it tells you that it creates a matrix of a given set of values. You can specify the number of rows and the number of columns. The number of rows is the desired number of rows you want and the desired number of columns you want. All right. In this case, I want, because this is 6, remember your number of rows and number of columns must multiply. They must be multiples of each other. So 3 times 2, that gives you 6. So what I'm trying to say is I want this to be 3 rows and 2 columns. So I'll run that and print mat 1. So you see that it takes 72, 76, 70, 72, 76, 87 and puts them on the columns. Okay. Let me get this. Okay. And puts that on the column and then picks 55 on column 1 and then picks 55, 64, 99 and puts that on column 2. All right. So here we have row 1, row 2, and row 3. All right, so that's why we have a 3 by 2 matrix. I hope that makes sense. So that's the first way to create your matrix. But then a question could come to say, when you notice what happens here, R automatically sets the values by columns. All right. And that is very clear when you read the documentation on the help file. You will see the by row argument inside here that is set to false by default. When you come down and read about it, it says it's a logical. If it is false, which is the default, the matrix is filled by columns. All right. So that's why when we created this matrix, it puts 72, 76, 87 first on the columns and puts 55, 64, and 99 on the second column. But we can do something and specify that we want this arrangement, the same matrix as well, of course, giving it a new name, and want it to be by row, which is true. So, right, so want it to be true instead of false, which is the default. So I'll run this and see now. You will see what happens here, that it picks, let's go back a bit. Yeah, let's go back a bit. Okay, so you will see now that it picks the values that we have there. It picks these values 72, 72, okay, 76, 76, okay. Okay, it picks 72 and puts 72 there, okay, and picks 76 and puts 76 on the rows. So it prioritizes arranging this matrix by rows, then picks 87, 55. You see the difference between this matrix and this matrix. Of course, they are still a 3 by 2 matrix, okay? But now it's a matter of priority. Which one does it prioritize? Is it the rows or the columns? All right, so that's what we try to show in the last few minutes. So I want you to quickly learn that for matrix, you might not be creating a matrix from scratch, honestly, but just know that you can specify things by rows or by columns. Okay, so we can create a vector. So this is an exercise for you. Create an integer vector from 1 to 9. I can just quickly do that. Int, I don't have to stress 1 to 9. Okay, and I can just create int. All right, and now I want you to create a matrix out of this. I want you to create a 3 by 3 matrix. 3 rows and three rows and 3 columns, and it should be arranged by columns. So priority should be given to the columns. All right. So I want you to pause my video. You call it Math 3. And I want you to pause my video at this point and try this out yourself. Okay, so I hope you're able to do that. I'm just going to run that and Math 3, and you see that it prioritizes arranging 1, 2, 3 by the columns, because by default, by rows is false. Now let's go to indexing, which is where we'll spend a considerable time here. Remember Math 2, the 3 by 2 column we created, rather matrix we created. Imagine I want to get the value on the second row and the second column. So before I get that, I want you to try to see if it's something that you would be able to understand or be able to see. So imagine that I want to get the value on the second row and the second column. What value is on the second row and the second column? That's a question for you. What value is on the second row and the second column? All right, the second row and the second column. So in this situation, that value should be 55 because it's on the second row and the second column. All right, so let's try and run that. So of course, the way we do it is we call the name of the matrix, okay, and specify the rows, comma, the columns. That's very important. So I'm going to run that, and that gives you 55. If you want to return all the second row, just put the value and comma, and that gives you all the second row, 87 and 55. If you want to return all the second column, that will be 76, 55, and 99. That returns 76, 55, and 99 as well. If you want to return the first 2 rows and the first 2 columns, so you see, this 1, 2, if you do this normally, of course, you know that will be like 1, 2, first row, first 2 rows, comma. Again, what separates the rows and the columns is the comma, not the column. The column is just a vector operator. And second column 1, 2. So I'll run that. So it gives you the first 2 rows and the first 2 columns. And like you learned from vectors, when you do -3 and -2, what does that tell you? Okay, and -3 -2. Let me clean this off. Okay, so -3 -2, as we learned under vectors, we remove the third row and the second column. So again, let's print out Math 2. Math 2. Okay, let me do some quick annotation here. So I want to remove -3, okay, and -2. That's this, of course, because it's -3, comma, that's the rows, comma, -2, which is the column. All right, so what should be left should be 72 and 87. That should be what should be returned. Okay, let's see what that works like. Let's run it, and that returns 72 and 87. I want you to try this for me. What do you think your Math 3 -1 and 2 column 3 will return? Okay, I want you to, okay, -1 actually, -1, right? So what I would do is print out mat3. Mat3 is the vector, the matrix we created, 3 by 3 matrix. So I want you to remove for me -3, -1 in the rows, and what do you think this will return? So I want you to think about this critically before you run it. I want you to think about this critically before you run it. Again, we're saying that we want to remove -1. So all of the first row will go out. And we want to return the column 2 and column 3. We want to print out the second and third values of other rows, basically. So that is, we want to return these two columns, column 2 and column 3. So I would imagine a result like this. 5, 8, 6, 9. I hope that was exactly what you did. So I want you to then run this remaining part yourself to see where that brings you and if it makes sense to you, if the result makes sense to you. Let's move on to the last part of matrix operations. Again, let's print out mat3, and that's your matrix of 1, 2, 3, 4, 5. You can do a scalar multiplication, and that just gives you multiples of 2's, and you can do a subtraction, multiply the matrix, the transpose of the matrix and the matrix. You can subtract that, you can multiply that, you can add that. Of course, the transpose of a matrix is just changing the rows to the columns. I think that should be covered in basic high school, right? So you run that, and that is the subtraction of the matrix and its transpose, the addition of the matrix and its transpose, its scalar multiplication, and the matrix multiplication. You can do all of this with R. And with this, we can switch to data frames. And like I said, a data frame is similar to a matrix, and we'll see what the difference is. So let's switch back to the slides to walk through this. A data frame is for storing tables, like your data tables, like all the data sets you have. They are data frames, basically, with rows and columns. The only difference between a matrix and a data frame is that, unlike a matrix, that it must store the same data type. So for example, the numeric matrices we've created that are vectors, for a data frame, it can store different vectors of different data types. So it can store, for example, grade, vec1, for example, like your normal data set can store age, which is a numeric vector. It can store, for example, residency, maybe rural or urban, which is a character vector. It can store whether they ate yesterday or not, true or false, which is a logical vector. But the condition is that they must all be of the same equal length. Each of those vectors must be of the same equal length. And like I said earlier, the data frame is a two-dimensional object as well. So indexing it as well will be through a two-dimensional means, rows, columns, similar to the matrix. I want to just talk about list because it's just the same approach. A list is like I'll call it like a dump site. It can store a variety of objects. So it can take matrices, it can take vectors, it can take data frame, and even other lists. All right. And to index a list, you use the double square bracket with the position of the element or the object you are trying to pick from the list. All right. And of course, you use the list function to create the list. Okay. And the final thing I want to talk about before we switch back to R is that R has missing values, or how R identifies missing values is either an NA missing value or NaN, not a number, something that is an undefined mathematical operation like 0/0. All right, that's not a number. It's not. If you do that on your calculator, it will say math error. All right, you can use is.na to check if something has a missing value. You can use is.nan to check if it is not a number. And of course, all NaN are NAs, but the converse is not true, meaning that something might be NA but not NaN. But every not NaN value is also a missing value. Okay, so with this, I'm just going to switch back to And let's tidy up this interesting walkthrough. Okay, let's create a data frame. We use the data.frame function to do that. There are different methods to do that. You can create it from scratch. You can create it using the vectors you have before. And remember that we had the vector grade that is of length 6, and we had vec1 that I created that was also of length 6. So make sure that they are of the same length. These two are two different vectors of two different data types. One is a character, one is a numeric vector, but they can be put together in data frame. I'm calling the data frame df and using the data.frame function. So I'm just going to run that, and you see that this looks like what you see as your tables. Now there are 2 columns and 6 rows. All right, I can return the element on the second row and second column. That is this second row, okay, and second column, that is 76, and of course that will return 76. And same indexing, I won't spend so much time on indexing here. As matrix, I can return those rows on rows 3 to 5. That is 3 to 5, and columns 1 and 2. So I'm returning C, D, E, and both columns. All right. And I hope that makes sense. One of the things that you will see a lot in R is the dollar sign or the dollar operator. It's simply to check to select a column, or a column in a data frame, for example. So if I want to select the second column, which is grade, I can just use dollar sign grade. So I can just say df, and when I type dollar sign, it will list out all of the columns that I have in the data, in that data frame. And I can do grade and just run it. All right, that returns the vector grade. Okay, Control L. And of course, we can also use these indexing operation where you can just put the second column and nothing for the rows, and returns the second column as well. We can check the class for each of the individual columns, and that returns that. In fact, we can even check the class of the data frame itself. So I can do class df, and that returns data frame. But for each of the individual, you see now that makes sense, right? Each of the individual columns or vectors in of these, it returns their classes, right? Their data types. I can return the third grade using this when I have picked grade column, and then I just use. So when I do this, you see how this concept builds on each other, right? When I do this, this becomes a vector essentially. And so how do I index a vector? I can just easily create that and just put 3 to the third grade, and that will return 87 for us. All right. We can create sub data frames as well by rows 1 to 3 and all the columns, and I can save that in another data frame. All right. If I run that and run this, and that you see rows 1 to 3 and all of the columns, the 2 columns that we have, and that makes sense. So if you check here, class of df1, it's also a data frame. All right. I hope that makes sense so far. We're coming to the end of this gradually. The second way to create a data frame is to create it from scratch, which you will likely not be doing, but I just wanted to show you. So here we have the data frame operation or function to create the data frame. I will list individual vectors inside of the data frame. You know clearly that I could have also created all of this outside of the data frame, the same way I did for here vec1 and grade. All right, but you can create it inside, and that's where the equals to comes in mostly, this assignment, the variable assignment. So I'm assigning a new variable name, 3 names, of course, my names. All right, ages, hypothetical ages, height, hypothetical height, and hypothetical salaries, right? And you'll notice that this is a character vector, this is a numeric vector, this is an integer, also a numeric vector, and they are all of the same length. All right, I'll run this, and that will run correctly. When I print out data, that returns this. You see, it's looking more like you see how concepts build upon each other. If I come here and add in an age, for example, let's say 21, and run this, let's see what happens. It throws up an error because now they are differing length, number of rows, right? Remember that a data frame, though, can store several data types, but they must be the same length. They must be the same length. So that is why that threw up an error. Okay. So we can go on to check. Of course, I think we've seen this before. DF grade, we've seen that before. Print the data frame. Okay. We can check the class is a data frame. We've seen that. Number of rows is one function I'm introducing to you, n rows. It tells you there are 3 rows. Of course, when you print the data frame again, there are 3 rows. N call is number of columns. There are 4 columns. You can see how we begin to get some information exploring our data. We can check the internal structure of this data by using the str function. Str function, so that tells us that it's numeric. The age is numeric, the height is numeric, the salary is numeric, and the name is character. It tells us the number of observation and number of variables. You see me use str a lot. Str is to check internal structure. You can check the column names of the columns in the data frame using the names up function. It tells you the column names. You can also use call names as well. So same thing, multiple ways in R. That also gives you the column names as name, age, height, and salary. When you do use the add function in R, it returns the first 6 rows for you. But because we have only 3 rows, I can specify how many rows I want. So I can say add data, the data variable you have created, and 2, that returns the 2. But usually, the add function returns the first 6 rows. Same thing as the tail function, it returns the last 6 rows. But because we have only 3 rows in this data, we can definitely just run that and returns the last 2 rows actually. Dim is to check the dimension, the number of rows and number of columns. So it tells you there are 3 rows and 4 columns. Summary is to get basic summary statistics, and that returns the basic summary statistics. You see, for the age now, that the minimum is 22, the first quartile is 23, the median is 24, the mean is 24.67, and some of those 5 number summary, the basic summary statistics in statistics. We can go on to create another data with the same names: name, age, height, and salary. All right. Of course, this, like I said, you will hardly be creating data from scratch. All right. So I want to add 2 new rows to this. Daniel. Oh, I'm missing an L here. Daniel and Abiodun, for example, age, new ages, and height. So if I create this, I have data 1. So what I want to do is I want to merge data and data 1 by the rows. So the condition is when you want to merge in rows, the column must have the same name. The columns must have the same names. So it will throw up an error if I try to change this to NAME. Remember, R is case sensitive, right? But let's try it first. Let's create a data frame 2. So the function that would append rows together is a row bind function. So R bind, okay? So I'll just run that, and you'll see now I have a new data frame that has joined these 2 data frames together. Okay, if I come here and say, for example, I'm creating this as maybe salary 1, okay? And I run this, okay? And I try to row bind it. It will throw up an error because see the error name. And that's one thing with R errors. It gives you the description. It says names do not match previous names because now I've changed this to salary 1. Even if I change this to small letter n, all right, and run it, it will still throw the same error that the names do not match. So it must match exactly to use row bind, all right? So now it will work correctly, and that works correctly. For C bind, meaning that I can add more columns. So currently my DF2 has 5 rows and 4 columns. Name, age, height, salary. I can add, for example, gender. So I can add gender, creating a vector of gender, and I'm changing that to a factor. I think we've seen that. And last name, for example, I'm adding last name to this. And the issue with column bind is that the number of rows must be the same thing. So the two things you're learning here is for R bind rows, the name of the columns must be the same thing for the two or multiple data sets. For column bind, C bind, the rows, number of rows must be the same thing. That's why I'm creating 5 here. 1, 2, 3, 4, 5. That's why I'm creating 5 last names. 1, 2, 3, 4, 5. All right. Okay, now with this, I can easily just merge it by column wise. And I have a long, now I can do dim. That's the dimension of DF3. And that tells you have 5 rows and 6 columns. All right. I can also rename a column name. For example, the first name here is name. I can change it to first name by just picking, see why we are using the column names function. So if I do column names DF3, I'm missing a bracket. So if I do column names DF3, now I'm missing this. It should be names, not N. So these are errors that you will see. All right. Column names, bracket, not square bracket, DF3, it returns the column names for you. And this is on position 1, position 2, position 3, position 4, position 5, and position 6. So I can easily just pick the one in position 1. The same way we replaced, remember, a vector, I can change that to first name. And when I print out DF3 now, you see that name has changed to first name. And one thing you can do with R is when you on your keyboard, on your arrow keys on your keyboard, when you press the up arrow key, you can go back to previous codes that you have run. All right, that's a good thing to do. So I can go back to column names DF3. And now when I print the column name DF3, you see that name has changed to first name. You can also use this approach as well to do the same thing. For example, I can change, but this looks longer. I can change height to height in centimeter, and it will do the same thing. So when I do column names DF3, you see that height is now in centimeter. And if I print out DF3, you see now that it's height in centimeters. All right, so that makes perfect sense. And the last time we talked about working directory, for example, this data I have created, I can save it in my working directory. I can save it as a data frame using the write.csv function. But to do that, I have to be in my right working directory. There are a couple of ways to do that. One way is to come to sessions, come down to set working directory, and come down to choose directory. Okay? And you can now navigate to the directory you are looking for, intro to R. All right, and you see that does the set working directory and pulls the file path for you. That's one way to do it. Another way you can do that is if this file you're working with is in the directory you want to be, you can just right click on this and see set working directory, and that will automatically set it to the directory of this file. So you have to be careful. So once your file is in the same folder as maybe the data set or where you want to work with, then you can just right click on this and just do set working directory. And now when I do write.csv and save this data frame as employees data, and I run that, it will not show anything, but when I go back to my data frame, to my folder rather, I will see employees data there. And when I open that in Excel, you'll see, for example, those files there, those columns that we created. I hope that makes sense. All right, so the last thing we want to look at before missing values is a list. A list is simply, it can take different things. So let's just put together all of the data frames, vectors, matrix, and vectors we have created. And you will see that you see the vector grade, you see the matrix mat1, you see the data frame we created, and you see the vec1 vector is the fourth list in the list. To access the first and second object, you just put a double square bracket that returns the grade. This returns the mat1 object in the list. If you want to access the fourth and fifth object, third and fourth object, I can just copy this and just change this to 3. And this will return for me the data frame, which is the third object there. And I can return as well the fourth object as well. All right, and that returns the vec1. You can return the first row of the third object, with the third object here is the data frame. You can return the first row, that is A and 72, and that returns A and 72. Okay, so by the time you index this out, it becomes the original object, which is the data frame, and then you can then index it normally. You can change the names from 1, 2, 3, 4 to name. So you can call this a vector, you can call this a matrix, you can call this a data frame, and you can call this a string using the names object, names function. So when I do that now, you'll see now that in this first case, we had it as 1, 2, 3, 4. Now it's called the names we give to it: vector, matrix, data frame, and string. And now to index it, now I don't need to use double square bracket. I just need to use the $sign. So if I do my list $sign, and then I can decide to choose, okay, I want the vector, all right, and returns the vector grade. I can also return the matrix, and the matrix returns 72, 55, 76, 64, 87, and 99. And I can index it to say return for me 2 and 1. All right, that's the rows 2 and columns 1. All right, rows 2 and columns 1, which is 76. All right, I can add a new object, for example, a logical, to this, my list. All right, and I just do that, and that adds the logical to the list. Okay. The final thing here is missing values. Like I said, missing values can be NA or NaN. If I create a second vector and insert NA there, that's a missing value. If you check vec2, you see that NA there. You can use is.na to check. So if I do is.na, it tells you that the third element is true because it's a missing value. All right. If I do is.nan, it says false because remember that NaN is Na, but Na is not necessarily NaN. I hope that makes sense. And I will illustrate that with the next example. So the next example, in this vec3, I'm having 2 NaNs and 1 Na. So it means that based on what I said, there will be 3 missing values, but there will be only 2 NaN values. I hope that makes sense. Okay, so if I do is.na, so you see that there are 3 missing values because the NaN is also counted as missing. Okay, Na is counted as missing. The third NaN, which is 0/0, is also counted as a missing value. But when you do is.na, only is.nan rather, only 2 of them will be seen as NaN. You see that the third one here, Na, is false because an NaN is not, an Na is not NaN. I hope that makes sense. All right, you can use any Na to check if there's any missing value, and you can use the sum is.na to check how many missing values is there. So you see that there are 3 missing values in this place because NaN is 1 missing value, Na is another missing value, and NaN is the third missing value. Now, this has been exhaustive going through data frames. Like I said, I anticipated that it's going to be really long, but it's the foundation. So please take the pain to go through it because you want to build a solid house, a solid foundation for your beautiful house in R, right? These are some other resources you can explore, and this will be continued in the third series where we'll be looking at packages and installing packages and importing data. And with that point, I think you can then pick your R learning journey from there. All right, thank you so much and see you in the next video. Biso biso.